We're doing lesson 3.4 Distributive Property from chapter 3. This is a very important concept, not only now, but moving forward. Distribute, what does it mean? To distribute means to give something to everything that is present there. For example, if I bring in candy and I want to distribute it to the class, then I'm going to give it to everyone that is in the class. This property is useful if we are just multiplying numbers, and sometimes numbers are harder to deal with, like 6 times 82. Then it becomes easier to do the math just in our heads, or mental math as they say. So I can rewrite 6 times 82 as 6 times 80 plus 2. Now I'm going to show you that I want you to do in every one of these problems. And that is that I want you to put the arrow when you're showing the distribution. So 6 is being distributed to the term 80, and 6 is also being distributed or multiplied with the term 2. So distributive property means whatever you have on the outside of parentheses is distributed or multiplied with every one of the terms inside the parentheses. Okay, so now I can rewrite this as 6 times 80 plus 6 times 2. 6 times, and now from here we know what to do. 6 times 80 gives me 480, plus 6 times 2 gives me 12, which adds up to 492. Let's move on and do an example with fractions. Again, here I have a 2/7, and it's being multiplied with 3 3/4, which I can split up and write as 3 plus 3/4. Again, I'm going to put the arrows which to indicate that the 2/7 is being distributed or multiplied with the 3, and the 2/7 is also being distributed to the 3/4. So let's go ahead and write these down. 2/7 times 3 plus 2/7 times 3/4. Let's go ahead and solve this. I'm just going to go ahead and put the 1 underneath just so it's straight in our heads. We know how to multiply fractions. This gives me 6/7 plus, I'm going to cross some things out here because I know how to cross them out. So 2 goes once into 2, 2 goes twice into 4. That gives me a 3/14. No addition of fractions. I'm going to go ahead and make them into equivalent fractions with the same denominator. So this becomes 12/14 plus 3/14, which gives me 15/14, which is nothing but 1 and 1/14. All right, let's do one more example so that it's clear how to do this. All right, now I have a 5/6, and I'm multiplying it with 2 and 3/10. That means I can rewrite the 2 and 3/10 as 2 plus 3/10. All right, let's rewrite it. First, I'm going to put my arrows. 5/6 is being distributed to the 2. That means multiplied with it and with the 3/10. So 5/6 times 2 plus 5/6 times 3/10. All right, let's go ahead and do this. I know I can put a 1 there. 2 goes once, 2 goes 3 times. Gives me a 5/3 plus 3 goes once, 3 goes twice, 5 goes once, 5 goes twice, plus 1/4. Now if you do this, you end up with, let me use another pen so that it's easier to see. I end up with 20/12 plus 3/12, which gives me 23/12, which is nothing but 1 and 11/12. All right, now let's move on and look at the distributive property in algebraic expressions. Let me go ahead and erase the board for that for just a second. And if you want to, you haven't followed, then you can just pause it, go back. All right. Okay, using the distributive property for algebraic expressions. Now, again, remember, we are multiplying everything that is outside the parentheses with every term inside the parentheses. So I'm going to distribute the 11 with the x. See how my arrow shows it? And then the 11 with the 7 also. I'm going to rewrite it as 11 times x plus 11 times 7. Now, we know that 11 times x is 11x plus 11 times 7 is 77. Now, can I add these two terms? Can I do anything with them? Not really, because they have, or they are different terms. That means unlike terms. They don't have anything similar, because remember, we talked about this in class. Like terms are the ones that have the same variable to the same power. Now, 77 has no variable. It's a constant, whereas 11x has a variable, and it has that. So this is my final answer. Let's do one more. I have a 8 times c minus 4. So I have a 8 times c, and I'm going to do a 8 times 4. Again, this little bit of 1 second step with the arrows will keep it straight in your head. All right, I'm going to rewrite this as 8 times c minus, because that's what it says, minus there, minus 8 times 4. 8 times c is 8c, minus 8 times 4 is 32. Can I really add them? No, because they are unlike terms. Think apples and oranges. You cannot combine them and say that many that many apples or that many oranges. So think about it that way. All right, let's move on to the last one. Now, there are a couple of ways to do this, and I'm going to show you one of the ways right now, which is I like to combine or put together the terms inside the parentheses before I distribute. Now, I see that 4 and 3 are inside the parentheses, and since they are like terms, I'm going to use my commutative property. Remember the commutative property where you could move numbers around? So I'm going to do 4 plus 3 plus r, and then rewrite it as 3 times 7 plus r. Now, once I have that, I'm going to go ahead and distribute the 3 with the 7 and 3 with the r, rewrite it as 3 times 7 plus 3 times r. 3 times 7 we know is 21, plus 3 times r is 3r. Can I do anything with it? Not really. So I'm going to leave my expression alone. All right. Let's go ahead and look at the last part of this lesson, which is combining like terms. That means I have some terms in this which I am going to put together and simplify, or go to the maximum that I can simplify. All right, let's take a look. I have a 9w plus 4 plus 2w plus 11. I see some like terms here. I have a 4 and a 11, which are just numbers, and I have a 9w and a 2w. Remember, coefficients, which is the number in front of the variable, can be different. Let me use on the pen. Remember, coefficients, which are the numbers in front of the variable, can be different, but the variables themselves have to be the same. All right, I'm going to rewrite it as 9w plus 2w using my commutative property plus 4 plus 11. I can combine these two. That means I can add the 9w and 2w because they are like terms. So that gives me 11w, 9 plus 2, 9, 10, 11, 11w, plus 4 plus 11 is 15. And that's my final answer. Let's go ahead and take a look here. I have 4 of these g's. That means I have 1 g. I'm just writing this. You don't. This is so that to show you that if no number is written or no coefficient is written in front of a variable, it implies that it is one, quantity 1. That gives me 4 of these, which is a 4g, 4g. Okay, now let's do the last example. This is, as you see, a little bit more complicated. I have some variables, and then I have a plus, and then I have a distributive property. So let's start with this. I'm going to rewrite it as 9c plus, and I'm going to put my distribution arrow. 3 goes with the r, 3 also is multiplied with the 2c. Okay, now I have a 9c plus 3r, 3 times r, you could say, minus, because the sign here says minus between the two terms, 3 times 2c. this ends up as 9c. Let me get the pen. 9c plus 3r minus 3 times 2 is 6, 6c. I'm going to use my commutative property and move these around and say 9c minus 6c plus 3r. Now, this ends up being, let me erase just this part here. Okay. And I'm going to sort of, oh, I cannot move it. Let me redo this whole problem again, just this piece, so that it's clear. All right, quickly. 9c plus 3 times r minus 3 times 2c. And then I have a 9c plus 3r minus 6c. The 9c and the 6c are similar, so I'm going to use 9c minus 6c plus 3r. 9c minus 6c gives me 3c plus 3r. Okay, I want you to go ahead and finish the rest of the problems using my notes and with the help of the homework, and I will see you next class.